This particular unit that I'll be using for my demonstration, the selection that I've made for my second channel, this unit actually has 2 channels, and the selection that I made is option 2. And that option 2, I can bring in a couple of different signals, and most often, those signals have an effect on the first channel. Whether it's changing the reading, that's what we're going to focus on here, is for pH correction, or maybe changing the way the control output is controlling the application. So again, option 2 on channel 2, this is for the milliamp input, well, I'm sorry, not necessarily milliamp input, the input to affect channel 1. We're going to use the pH correction. Some of the other options under that channel 2 selection for option 2 would be a milliamp input to change the set point remotely. So if we wanted to have some automation on how we adjust our set point, we could do that with option 2. Also a feed forward signal, we can use that for channel 2. And we can also change with a digital input some of the control parameters. We're going to focus again, typical setup for a unit that is controlling chlorine. So we're going to be feeding sodium hypochlorite. And when we feed that and measure with our CLE sensor, which we try to measure HOCl, we typically refer to as free chlorine here. As our pH changes, it has a very big effect on the HOCl. The HOCl, as the pH increases, changes to OCl minus. We can measure that with our CTE sensor. But the OCl minus is not as efficient a disinfectant as the HOCl. So it would be better for us to be measuring and actually using in our system HOCl. So one of the things we are challenged with is to match the DPD type test. And that's the same test that our DT calometric test kit does for us. And that test kit, when we take that 10 ml sample, 10 milliliter sample, one of the things we add is a buffer. So we buffer that sample back down to very close to neutral, and that makes it look like we have HOCl in our application. So to match that calometric test, that DPD test, we have to use a logarithm built into the unit, and that's our pH correction. So it's very common for us. It's a very practical application here, and we're going to go through setting those up. And just from going through this application, I think it will cover how to set up some of the other parameters that might be not exactly a chlorine and pH type measurement, but it should, again, kind of refresh us on how to go through those menus. So I think we'll begin now, and you can see right now that this unit, although we have a second channel on this unit, it is only displaying one of those channels currently on the display. So we're going to go through and we're going to change it. Right now it's actually showing it as measuring bromine. However, we are going to change that channel to be measuring chlorine. So the first thing we do is simply hit the menu button. Once we press that menu button, you see that it brings up a list of all the menu options. And the one that we are going to enter once we hit the OK button is highlighted with a small little cursor to the left in that column to the left of all of the menu options. So the first thing we need to do is go to our measurement menu. So you see I press the down arrow, I move that cursor down, it's right next to measurement. If I press the OK now, it gives me my measurement options. You'll see measurement channel 1, it's selected right now to bromine, and measurement channel 2 is selected to none. That's why when we were at that main display, we only saw the bromine being displayed there. So I want to change that. I want to change that, so I'd simply press the OK when my cursor was next to channel 1. And now the cursor is at the top line, which reads measured variable. So measured variable, I simply press the OK. Now I can scroll with the up or down arrow button to select whatever I want on that first channel. And I do want chlorine, so I'm going to select chlorine by pressing the OK button. And now you'll see that channel 1, my measured variable, is chlorine. Here the sensor type is CLE. If I wanted to change that, I simply move my cursor down, press the OK button, and I can select any type of my chlorine sensor. So I am going to select CLE because that's what we typically use to measure the HOCl. And once I have my CLE 3 or my CLE 3.1 highlighted in that box, I'm going to press the OK button again. So just to confirm, our sensor type is our quote-unquote free chlorine. The next thing I have to select is my measuring range. Here, the first one that's going to come up is my 0 to 2 ppm. So again, if I want to change that, I've moved my cursor down to measuring range, press OK. Now I can scroll through with the up or down arrow button to get to wherever I need to be, and I am going to select a 10 ppm sensor. So again, it confirms to me my measuring range is a 0 to 10 ppm. I can select if I have a temperature input, I can turn that on, and pH compensation, we're going to come back to that. We are going to turn that on, but I'm going to tell it that channel 2 is my pH sensor first. So to do that, I'm going to hit escape now. And once I hit escape to go back, it asks me to verify those changes that I just made. If I am not certain that I want to verify those, I can hit the escape button to go back and verify those changes that I made. If I'm certain of those changes, I simply hit the OK button to confirm those and save them into the unit. So now we're confirmed on channel 1. We want to set up channel 2. So I move my cursor to channel 2, hit the OK button, and now you'll see that I have a very limited selection on channel 2. I have pH via a millivolt signal. Remember, our pH sensor generates a millivolt signal typically. So that's going to come in. And in the past, when we had the D1CA for pH correction, it had to come in as a milliamp signal. Now we have a little bit of an option. So that option being, it can actually come in as a millivolt signal. We don't need the signal converter because remember the sensor is generating a millivolt signal. If we needed to convert that, if we need it to come in as a milliamp signal, we need to convert that. And that converter that would thread directly on top of the prominent pH sensor is part number 809126, I believe. For my simulator, I am going to bring it in as a milliamp signal. So now this is simulating as if I converted that pH sensor with my transducer, my signal converter, 809126, and I'm bringing it in as a milliamp signal. So I'm going to select pH as milliamp. I'm going to click OK. I can select how many decimal places to display. If I have a temperature input on this channel 2, I can turn that on. And then also, if I have potential equalization, if a pH sensor is in a stream of water that has electrical noise embedded in that sample line, it's only a millivolt signal, remember, that pH sensor is generating. So if there's any type of electrical noise that's being picked up by that water stream, that sample stream, it can affect that pH reading, and it can be pretty significant. So to give the DAC a reference to what that noise is, we can select that potential, and then we have to run a wire to the water sample stream to sort of to reference that noise that's in the water, so it can eliminate that from the pH sensor's reading. We're not going to use that in this case, but this is where we would select it if we did have that. So I'm going to hit the escape to go back. Again, it's going to ask me to confirm those changes that I just made. I'm going to verify those with the OK button. So I come back to my measurement screen. Remember, I have to go back into channel 1 now and verify that my pH compensation is on. So I'm going to scroll my cursor down. You see I move my cursor down in the left to where pH compensation is. I'm going to select the OK button, and I'm going to simply turn that to on. I'm going to scroll with the up or down until I get to on. You can do that manually. If your pH is high, and it's always high and it's always stable, but it's high, you can dial that number in by selecting manual and then telling the unit what that pH actually is. However, I'm going to select the on, and we're going to do that with one of our pH sensors. So now it's verifying that on channel 1, I'm using pH compensation. If I hit the escape button to go back, it's going to ask me to verify that again. Click the OK. And here are measurement types on chlorine and pH. So if I hit the escape again, I go back to my menus, my main list of menus. I can scroll down to control, because we're going to control the chlorine. And I'm going to control channel 1, parameter set 1. Currently that control is off. I'm going to turn that to on. And I have to select how I am going to control that. What additional functions am I going to use to help that control output signal really maintain my set point that I desire? So for this example, I'm going to select the full PID in one direction. Typically, when we are controlling a chlorine application, we are adding sodium hypochlorite to increase our chlorine reading. There are very few and far between instances, examples that I can think of, where we are doing two-way control. In other words, we're adding chlorine to increase the reading, and then we're also adding a chemical at the same time to keep that reading lower on chlorine. Sometimes we do that in pH applications, and then we can control with a dead man. But for this application, we're going to actually use the PID one-way control. So I'm going to select that, and I'm going to select OK. So you can see this goes further into that selection. My type is verifying PID one-way control. My control direction is increase. Again, we're going to be pumping sodium hypochlorite to increase our chlorine reading. My set point, I'm going to change my set point. And in the past, we had to simply hold the up or down arrow button to adjust that set point to where we wanted it to go. I could still do that. You can see that as I change that, it's going to change. But what I have now, the newer feature, I can move over whichever digit I want to change specifically, and I can change that with the up or down arrow button. So that's a very nice feature. It can save us some time. So I'm going to change that to a 1 ppm. That's my set point. I'm going to try to control my chlorine to 1 part per million. So I'm at 1 part per million. I'm going to press the OK button, and it verifies for me. My PID settings are here. We're not going to cover those too much. I'll review the XP, the proportional control, ever so slightly here. My proportional control is set to 1 part per million. That means I have to be 1 part per million below my set point. In this case, my set point being 1 part per million. If I'm 1 ppm below that, I would be reading 0 on my display before my pump that I'm controlling reaches 100% speed. So it's dosing at its fastest possible speed. I have additional basic load that I can add. If we know that we want the pump to run at a particular speed whenever we start and stop, and it's kind of the minimum that it's going to be adding in, at least a starting point for us, we could add that as a percentage to run our pump at. We can do this off of a time control as well. So that's a new feature. That's something that we have available to us now. Here in this example, we're not going to be setting that. That's not something that we're going to go into. We also have a control range limit as 100%. We can limit how much pumping rate we have, again, with that control range limit. But in this example, we're going to want the pump to potentially go up to 100% of its speed. We have a couple of other ways we'll discuss on how we could potentially limit the maximum speed of that pump. So we set our set point. We talked very briefly about the proportional control amount, and that's all we're going to cover on the PID settings for now. That PID itself could be at least one webinar, if not several webinars, that we could talk about that. So we're going to kind of go over that just very quickly. Here again, we're in the control menu. So you can see that we can also select control on channel 2. And if you remember, our pH sensor is on channel 2. So that means we can also now not only correct, it's not only a correcting value, but we can also control that pH, which now that's much better for us. Now we can control, if we do have a high pH in our application, we can add some control, bring that pH back down. Our chlorine is much more efficient. It does better disinfection just from the chemistry side. And we don't have to add quite as much sodium hypochlorite. So this is a very nice new feature that we have on the DAC. So we'll go into that channel 2. Right now you'll see that the control is turned off. I'm going to change that. I'm going to go to PID. Let's do PID in 2 directions here. So you'll see that the behavior is can be either increased or decreased. You saw that on the chlorine sensor. We're going to leave that to standard. I actually digress on that. Let's go back to select that on channel 2, my parameter. I want to do one-way control just because I want to show you that we're going to be adding acid. And one of the things that we have to do to add acid would be change this control direction. And now it's going to be in the decrease. Okay. So when we select decrease here, the unit knows that we're going to be adding an acid. Our set point is very close to neutral. It's a pH of 7, which is nice because that's in the middle of our measuring range. Our XP, again, it's a fairly low percentage of that, 1.54. We're not going to cover that so much right now. Additional basic load, the control time and the control range limit, the same as we talked about on channel 1. We're not going to take advantage of those right now. We're going to go back. So now not only are we using that pH measurement as a correcting value, but we can also control from that. Here on this control stream, you'll see a disturbance variable. We can tell it if we have a signal from a water meter telling us that the flow in our process has changed. And that change means that we can either speed up or slow down the pump. The chemical feed is essentially a ratio of the process flow to the chemical flow. So we might not need quite as much if the flow goes down, or we might need significantly more. This gives the controller a little bit of an advantage to speed up or slow down the pump before it actually does its measurement. The set point setting via a milliamp, that would be if we wanted to remotely change that set point. We're not going to do that here in this example. And then parameter switching. If we wanted to, for example, right now we're controlling chlorine. if we wanted to change that to measure and control, say, bromine or chlorine dioxide at another point in time throughout the day, we simply change the state of that input. So that digital input, we would close that input, for example, and it would change to chlorine dioxide as our control parameter. But we're not doing that here on this example, but it is a nice feature that the DAC does have to offer. So I'm going to escape back out of that. The limit values are if we're using the relays here below, and most of the applications that we have, I would say a majority of them, we don't take advantage of those limit relays. Sometimes we do. That would be, we're just trying to cover here the more common applications that we have. So we can use those. That's covered on some other webinars that we had in the past, but for this example, we're not going to cover that. The pumps. Here, we're going to tell it what the pumps are assigned to. So pump 1 for channel 1, you see as an increase, the maximum stroking rate is set to 180 strokes per minute. So we are going to increase. This is going to be our pump to add sodium hypochlorite to the application. However, the maximum stroking rate, we may have a delta pump, or we may have one of the sigma pumps that are able to do a higher flow rate. So we're going to set it to 200 strokes per minute. Now, we might be with a sigma control version pump that can only do 90 strokes per minute. And this is where we would set that stroking rate. This is the maximum stroking rate. As I mentioned, this is one other place that we could limit the maximum stroke rate of the pump. If we're using the contact, if we're running the pump in the contact mode of operation, and even if it's a gamma L pump, if we set this to, for example, 90 strokes right here, strokes per minute, just as a random number, or 80 strokes per minute, that pump would never exceed that stroking rate. So now we could kind of maximize the sodium hypochlorite feed into the system through that pump. So this is the screen where we would do that. So I've moved it up to 200 strokes per minute and hit escape. I don't know why it didn't increase from 200. Sorry about that. Okay, I didn't hit OK before. Sorry about that. Now you can see it's confirming that pump is capable of a maximum of 200 strokes per minute. I hit escape. I'm going to go down to pump 4. That's going to be on channel 2. I have an increase pump and a decrease pump. So that second pump on channel 2 is going to be my decrease. Remember, we are adding acid to lower the pH reading. We're on channel 1, we're adding sodium hypochlorite to increase the chlorine reading. Here on channel 2, we're going to have a pump to decrease or add acid to the system. So you can see my maximum stroking rate is 180. That's fine. I'm just going to leave it there. We'll assume that it's either a beta pump or a gamma L pump. And I could go in and turn off those other pumps if I elected to, but here for this example, I don't have to do that. It's going to be what I'm connected to, what I'm wired to anyway. So now I go to my digital inputs, and here, since we are controlling, there is one digital input in particular that is very critical to us, and that is designated as input 1. This is my flow signal. It's verifying that I have flow in either my process and or my sample line. So my function right now is off. I'm going to go in to change that. I'm going to change it to, I can change it to pause. That means that if that digital input changes state, my control outputs go into a pause. They stop whatever I'm controlling. The other selection that I have here, which is a very nice selection, is pause hold. So after the PID settings that we have programmed in adjust the speed or adjust the control rate that are coming out of our pump, if we just pause and then restart, it sort of starts over to recalculate that best running of our pump. If we use pause hold, now it starts over where it left off. So if the pump was running at 23% before it went into the pause, when the pause goes away, when our flow comes back, the pump is going to restart at 23%. So that's a very nice feature that we have. I'm going to leave it at pause hold. You can see my status is active closed. The flow switch that is on the DGMA assembly, that has both sets of contacts. That's form C. It has a common. One is normally open and one is normally closed. So one is active open and one is active closed. So I can use that as my input, and depending on how I wire that. But if I have multiple inputs, if I have an input from a contact that I use from a motor starter that's from a booster pump in that process also that controls the flow, I can also have that either paralleled or series into that input. So I can use, again, either side of that flow switch from the DGMA, and I can have it, if either one of those change states, that control output stops. So that's something that you can use there as the status as for what it's looking at. My fall delay, so I can give it a little bit of time to look at that. Alarm, that's a nice one also. If either of those change states, either the switch on my DGMA or maybe the input from the motor starter that we are taking advantage of, if we are taking advantage of that, and this unit goes into a pause, if it stops the control output, I can make that activate my alarm relay inside of the DAC. So I can make someone aware that flow is stopped. If they know that the process should never stop, if it does stop, they want to be made aware of it, we can let them be aware of that change in flow. Right here is the assignment. What is it going to control? Now remember, we're actually set up to control off of both channels in this example. So by default, it's on channel 1 only. We actually want to scroll until it's on channel 1 and 2. We want it to pause not only our chlorine feed, our sodium hypochlorite feed, but we also want it to pause that acid feed. The premise is if that process is stopped and we're stopping those control outputs, we're stopping it so it's not feeding into a line that is stagnant. Okay, so that's a very big safety concern, and we can take advantage right here to make it for both channel 1 and channel 2's control. So that's very good. We're not going to take advantage of any of the other digital inputs right now, so we're going to leave that menu. We're going to go to our current outputs. We have 2 current outputs currently on the DAC control. You see milliamp output 1 is currently set to off. I'm going to turn it to on. And I'm going to set it to a measured value. So now I am sending this milliamp signal out to the customer, and they may be using it for a remote display. So they have a display up in their office, and they want to see what the unit is reading down in the control room. So we transmit it up to the office via a 4 to 20 milliamp signal, and they can have a loop display up there. We can also control pumps with it, though. So the control variable, we can turn that to on. Then we would have to assign it, whether it be channel 1, tell it the range. Current error here, if we want to let that remote station know that it is in error, we can send out, say, 23 milliamps to that display. So if they're seeing 23 milliamps, they can assume that unit is in fault for some reason, and they have to go down and address that reason. Here, 4 milliamps, we have to set to 0. So I will scroll just to the first digit, change that. I'm going to change that to 0. Click OK. So now you see that 4 milliamps is 0, 20 milliamps, the pump would be running at 100% if we're using this for control. Milliamp output 2, I'm going to use for channel 2. So that's my pH measurement. I'm going to use it as a control variable. Here I'm going to change it from channel 1 to channel 2 because I want to control my pH potentially. And my output range 4 to 20. Current error, I'm going to leave that off. A lot of people are not set up for that, but if they are, we can provide that for them. Here, my 4 milliamps, again, I'm going to set as 0%. However, when I go to my 20 milliamps, remember we're feeding acid at this point. So I actually want that to be a minus. I want it to be minus 100%. So it's set to minus 100% now. I can hit my escape, and my milliamp outputs are set as well. I have diagnostics, and I have setup. The one thing I do want to show you in the setup screen, if we're not using our milliamp outputs to control pumps, the customer may need those for something else. So one of the things they commonly like to see is data logging. But remember now, we have the SD card, the data logger built right into the DAC. So we don't need to consume those milliamp outputs for a chart recorder. If they were taking that to a chart recorder, just a data log, we can do that internally right into the unit. If they're taking out the SD card, we have to go into the setup menu, go to the extended settings. Here we're next to the SD card. We press the OK button, and we see remove. So when we want to remove that SD card, we simply hit OK, and it would allow us to remove that SD card without any problem. It's just like if we had a USB attachment to our computer, we stop that USB attachment before we remove it. This is kind of the similar type process that we have to go through. That's all we're going to look at in the setup menu for right now. And I think that covered quite a bit here. Do we want anything else? Setup. I do want to cover this under the general settings in the setup, the time. If you get the unit here from us in Prominent in Pittsburgh, we program it with our computer, and it's going to be started with our local time, which we're in East Coast time. So you're going to see that time displayed. If you're throughout the U.S. or wherever you might be, you need to change this time, because if you are taking advantage of that data logger, it's going to stamp everything with the time of that operation. So it's very important that we go through and we change that time. You can change the date as well. The date mode for us here, we usually go month, day, year. We can change that as well. We can have it display there. If we do have a temperature input, here in the U.S., they use the Fahrenheit system. If you need it in Celsius or centigrade, you can change that here as well. The display refresh, the contrast and background lighting, you can change that also. I'm not going to change that. I'm not going to show you changing that because we're set up where it's pretty nice and efficient for the display on the webinar that we're doing here. Language, if we need to select a different language, obviously in setup we can do that. Authorization is another one we can go over real quickly. I'll show you. You have 5 passwords that you can set on the DAC. and the administrator, they have privileges to change anything, and then you can limit what you have the other 4 users having access to. And it's nice when you do set those if you're in a situation where people frequently change settings. Now, when they change something after they've entered their password, when that event happens, that is stamped onto our data logger. So the SD card is going to record who made the change and what time they made that change. So that's a very nice feature that's available from the DAC. So I think we're all set as far as our parameters. You can see right now that our chlorine reading is 6.06. Our pH is 8.43. So with that pH being so high, it corrects up to 6.06. I'm going to change my input for my pH, my simulator on my pH input. And you'll see just by changing that, by lowering my pH down closer to neutral or below neutral, here I went, you'll see that my reading on my chlorine changed very significantly. So I'm very close to neutral here, a little bit below it yet, but you'll see that the chlorine went from 6 without changing the input at all. It went down below 1 part per million. So that's very significant. You can see the effect that the pH has on the chlorine just from that example. To the left here, you see my stop is flashing. I can hit the start stop button to change that. And you'll see that right now, for channel 1, my chlorine, I'm below my set point. My set point over here on the far right, in that far right column, is 1 part per million. So it would be running the pump at 27% in this example. So you can see it's trying to increase. Right now I'm below my set point for my pH, so it is currently stopped. The warning at the bottom, warning 01, I can see what that is simply by pressing the OK button. You see I have warning 01 for channel 1, and my cursor's next to that. My limit has been undershot, so I'm below my limit setting. Even though I'm not using those limits, if I'm not using them, it's best to turn them off. But here, we didn't address the limits, so I'm actually below my limits. And one thing you can see, actually that arrow flashing below my part per million reading, that's my actual limit. So if I come back up above that limit slightly, see if I can adjust that ever so slightly up. Goes above there, and that warning will go away. Now the only warning I have is 04, so I click OK again. Warning for channel 2 is 04, and it tells me the channel has not yet been calibrated. So I click OK just to verify that I read it. I also want to look at channel 1, and it's going to tell me the same thing. Warning 04, it hasn't been calibrated. So every time if I program this unit to change my parameter, I have to do a calibration. So I'm going to step through the calibration for channel 1 simply by going to my menu. I can do this a couple of ways. Here I selected menu. I can go to calibration and hit OK, or I can simply hit the calibrate button. If I hit the calibrate button, again, I move my cursor to channel 1, press OK. I want to do a slope calibration. Typically, most often, I don't have to do a calibration for the 0 point. That factory default 0 point, when I'm using the prominent chlorine sensor, is most adequate. So we don't recommend doing the 0 point calibration. If you're getting strange readings, you might call in to get some technical support, and we might tell you to do a 0 point reading. But for now, we're not going to cover that. One of the other things, through the calibration routine, you'll see that there is a little indicator, a little gauge at the top, and it indicates what part of the process that we're at. So we're just starting the calibration process. You'll see that that first block is highlighted. So again, my cursor is next to slope calibration. I'm going to hit OK. It's telling me that the concentration is reading 3.38 ppm, and the current actually coming from that sensor is at 9.76. So it's a lot of information that's supplied that we didn't necessarily have in the past. We weren't able to see the current coming from the sensor unless we went to the 0 point reading. But then at that point, it was risky because if we could change that to actually be our 0 point, and that would cause it to read incorrectly. So we've removed some of that risk, but we can still see the current coming from the sensor. Here it tells us, wait for the stability of the measured value, remove my sample, then further go to the next step by pressing the calibrate button. So my reading is very stable because I'm using my simulator right now. I press my calibration button, and it says measured value upon sample extraction. What am I actually measuring in my DPD tester? So I use my DT calorimetric test kit to come up with a number, and I want to match that now. So with my cursor next to that number, I can click OK, and I can move across and change any one of those digits. I'm using my simulator, so I know that that reading is true. So I click OK just to verify that. It says change with the OK button. I've done that already, or continue with calibrate. So I'm going to press calibrate. You'll see that my slope is perfect. It's 100%. It dropped just a hundredth of a milliamp per part per million. And my 0 point, it verifies my 0 point again. So it says continue with calibration. That means channel 1 is done. So if I go back to my main display now, I still have warning 04. When I press OK, you'll see that only channel 2 has that warning now. So now I have to do a calibration on channel 2 as well. We're not going to go through that. The calibration on the pH is actually, we typically recommend 2 parameters. So we use buffer solution. Typically we use 7 as our first buffer solution. And then we use pH buffer either 4 if we're typically in the caustic range, or a buffer solution 10 if we're in the caustic range, or 4 if we're in the acidic range. So we're not going to do that calibration right now. Again, this unit is going to step you through it. It kind of takes you, it leads the way right through there. It tells you either hit the calibration button or the OK button at any given time. So it's very, very intuitive for us. So one of the other things we can do here is if we press the I button, which is also the right arrow button, it changes our display and it gives us a lot more information. This screen is very helpful to us, particularly when we're out starting up a unit. We can see a lot of information all on one screen without having to scroll through. It tells us our measured value on channel 1, we know is 3.38 ppm. The raw value, that's again the current coming from the sensor, is 9.78 milliamps. W is our set point. We changed that to 1 part per million. Our control variable is 0. We're above our set point right now. Our pump 1 is at 0 strokes. Pump 2 is at 0 strokes also. On channel 2, the same thing. Our pH measurement is 6.28. The raw value is actually 42 millivolts. Remember, that sensor is generating millivolts. Even though in our example, we're converting that to a milliamp signal. That milliamp signal represents a range of millivolts. So we're kind of translating it back to millivolts for our display here. Our set point on pH is 7, and our control variable is 0 in this case. So we're pretty close. We're a little bit below. It might jump up from time to time for us. Disturbance variable, again, that's from our water meter. We have that turned off right now. Current outputs are both at 4 milliamps. Relays 1 and 2 are both left to off, and the alarm relay is not active at the present time. So that's a very good overview of our DAC, how we would go about setting that up for a chlorine application, particularly a chlorine application with pH correction. If you have any questions right now, please type those into the toolbar. There's on the GoToMeeting webinar has a question section. So if you type those in right now, it would be very helpful to us. We could do that. Okay. One other question was, why did I program the 20 milliamps for a minus 100% for the acid feed? That's a very good question also. We know that the positive direction, we increase our feed, and the negative direction is for decreasing, not the feed, but the reading. So in the case where we're adding acid to lower that pH reading, we have to set 20 milliamps equal to a minus 100%. And that was the same way we did that on the D1CA, and the D1CB has to be done that way as well. Remember, the D1CB is still available for us. It doesn't have pH correction, but if we're using that to decrease any of those values, if we're controlling to decrease, we need to set that control output to minus 100. Okay, that's a very good question. If you don't, if that's not clear, if you still have a question on that, follow up with me. I'd be happy to help through that. But hopefully that explains it for you.